Hey everyone, A&M here. Today we're diving into something truly fascinating. Ever wonder how the internet actually works? I mean, we use it every day, but do we really understand what's happening behind the scenes? It's like magic, right? You click a link, and boom, a website appears as if by some digital sorcery. But there's no magic involved. Instead, it's a complex system of protocols and technologies working in harmony. Behind the scenes, there's a whole lot going on. Massive data centers, countless servers, and intricate networks all play a part. It's all thanks to the OSI model. This model is like the blueprint for how data travels across the internet. Think of it as the internet's secret language, a set of rules that lets computers talk to each other seamlessly. The OSI model breaks down internet communication into 7 distinct layers. Each layer has its own unique function. Each layer has a specific job, kind of like departments in a company. They all need to work together to achieve a common goal. They work together seamlessly to make sure your data gets where it needs to go without any hiccups. In this essay, we're going to dive into each layer, understand what they do, and see how they all fit together. We'll explore the physical layer, the data link layer, the network layer, and so on. By the end, you'll have a much better grasp of the magic happening behind your screen every time you browse the web, send an email, or watch a cat video. Let's get started. So buckle up and get ready for a deep dive into the internet's secret language. First up, we've got the physical layer. This is the ground floor, the foundation of it all. The physical layer deals with the physical transmission of data over a medium. Think cables, connectors, wireless signals, all that hardware stuff. This layer is all about the ones and zeros. It takes care of converting digital data, your emails, cat videos, everything, into electrical or optical signals that can travel through wires or wirelessly. It's like the delivery truck of the internet. It doesn't care what's in the packages, it just makes sure they get from point A to point B. Now that we've got our physical connection established, we need to make sure the data is organized and sent correctly. That's where the data link layer comes in. This layer is responsible for error detection and correction. It also ensures that data is sent to the right device on the network. Think of it as the postal service of the internet. It takes the packages from the delivery truck, physical layer, puts them in envelopes, frames, and adds addresses, MAC addresses, to make sure they reach the correct destination. Okay, so we've got our data packaged and addressed. But how does it actually find its way across the vast expanse of the internet? That's the job of the network layer. This layer is all about routing. It uses IP addresses, like a global address system, to figure out the best path for your data to take. Think of it as the GPS of the internet, guiding your data packets through the intricate maze of networks to their final destination. Section 5, Layer 4, Transport, Reliable Data Transfer. We're getting close. The transport layer is like the quality control department of the internet. It ensures that data is delivered reliably and in the correct order. It uses ports to direct data to the right application on your computer, and it can even handle breaking down large files into smaller packets for easier transmission. Imagine sending a huge package. The transport layer would be responsible for splitting it into smaller boxes, numbering them, and making sure they all arrive in the correct order and are reassembled properly. Section 6, Layer 5 to 7, the application layers. These layers are crucial for the end-user experience and are often the most visible parts of the OSI model. We've reached the top layers. These are the layers that make the internet and various applications come to life. Layers 5, 6, and 7, Session, Presentation, Application, work together to provide the services that users interact with directly. They ensure that data is properly managed, translated, and presented in a user-friendly manner. This is where things get really interesting. These layers are responsible for the seamless experience we have while using different applications. The session layer manages the connection between two devices, like when you're on a video call. It establishes, maintains, and terminates the connections, ensuring that data flows without interruption. It makes sure the conversation flows smoothly, handling the start, maintenance, and end of communication sessions. The presentation layer translates data into a format that both devices can understand. It handles data encryption, compression, and translation, making sure that the data is readable and secure. It's like a universal translator for computers, ensuring that data is presented in a consistent and understandable format. Finally, the application layer is what you actually interact with. This layer provides the interface for the end user and is responsible for displaying the data in a way that makes sense. It's your web browser, your email client, your streaming service, all the apps that let you do stuff on the internet. These applications rely on the underlying layers to function correctly, providing a seamless and intuitive user experience. Section 7, Data's Journey from Keyboard to Screen. Let's see all this in action. The journey of data from your keyboard to the screen is a fascinating process. Imagine you're sending an email. You start by opening your email client and composing your message. First, you type your message and hit send. This simple action sets off a complex chain of events. The application layer, which is your email client, packages up your email into a format that can be transmitted over the network. Next, the presentation layer comes into play. It formats the data, ensuring that it is in a readable and standardized format. Then the session layer establishes a connection with the receiving email server. This layer manages the sessions and keeps the communication open. The transport layer is responsible for breaking the email into smaller packets and numbering them. This ensures that the data can be reassembled correctly at the destination. After that, the network layer adds IP addresses to each packet and determines the best route for the data to travel across the network. The data link layer adds MAC addresses and includes error checking information to ensure data integrity during transmission. Finally, the physical layer converts the data into electrical signals and sends it through the wires, whether they are copper cables, fiber optics, or even wireless signals. These steps happen in reverse on the receiving end, with each layer doing its part to ensure the email arrives safely and completely. The receiving email client then reassembles the packets, checks for errors, and presents the email to the recipient in a readable format. Section 8. Conclusion, the OSI model, making the internet work. So, there you have it. The OSI model might seem complicated at first, but it's really just a way to break down a complex process into manageable chunks. Each layer has a specific job, and they all work together seamlessly to make the internet the amazing tool it is. Next time you're browsing the web, remember the invisible army of layers working behind the scenes to make it all happen. Until next time, this is A&M signing out. Peace.